Hello guys, welcome back to another video on JavaScript series. In this video, we'll be talking about this keyword. So to understand this keyword, firstly, we need to understand what is strict mode and non-strict mode, because the value of this keyword varies in strict mode and the non-strict mode. So firstly, let us see in non-strict mode, which is the regular code that we write, which we also call as sloppy mode. So if we understand how this keyword works in sloppy mode, then we can easily understand in non-strict mode, in strict mode as well, as there is only one minor difference. So this keyword, unlike other programming languages in JavaScript, we can use anywhere, which means we can use inside a function, we can use inside a method of a class, we can use inside a method of an object, we can use globally as well. So that this keyword in JavaScript can be used anywhere, literally. So firstly, we will see what is the value of this keyword when we use it in global scope. And remember, I'm using the sloppy mode, which is the regular code that we write, which we also call as non-strict mode. So being in non-strict mode or sloppy mode, if I use this keyword globally I mean by not inside any function. And then if I use locally means inside some function. So in global and in non-strict mode, this keyword always going to point to the global object. It will always be pointing to the global object. And in the case of Node.js environment, the global object is just the global. So if you print the variable global, you'll get what is the global object in Node.js environment. And in the case of browser environment, the global object is going to be the window object. Now locally, when I talk about locally, which means inside a function. So we have two types of functions, like a function, regular function that was there before ES6 version, and then arrow functions which were introduced in ES6. So we need to see in both the scenarios. One is in regular functions, and then inside arrow functions. And remember, inside regular functions, when we use this keyword, this keyword always points to the object which invokes the function. The object which invokes the function. Okay. And there might be scenarios where we do not invoke the regular functions by using any object in front of it. Firstly, what do I mean by object which invokes the function? Maybe let's say there is a function called f1. I might be calling this f1 by using some object obj dot f1. So here the meaning of calling f1 is by using the object obj, right? So this is what calling the function by using an object. And similarly, there might be a scenario where we might be calling a function by using obj1 dot obj2 dot the function f1. So in this case, the function f1 is invoked by obj2, which is a subobject of obj1. So this is what I mean by invoking the object by using it, invoking the function by using an object. Now, in regular functions, this keyword always points to the object which invokes that function. There might be a scenario where we do not be having the objects which might be calling the which might not be calling the functions. So in such cases, this keyword is going to be replaced with the global object. So I'll just simply say replacement of this keyword with the global object, with the global object. And remember, this only happens, the replacement of this keyword with the global object being inside a regular function only happens when we are in the sloppy mode or non-strict mode. Okay. And I will also deep dive into it when we enter into the strict mode later. Now, in the case of arrow functions, this keyword is not defined. I think you know what is the meaning of not defined in JavaScript. Not defined means that is not at all present within the scope of that function. So if the variable is not defined inside a function, which means that the variable cannot be found within that function. So this keyword is by default in arrow functions is not defined. So the value of this inside arrow functions will be accessed from its lexical parent. We just need to follow the scope chain rules. So it will be accessed from the lexical parent. Now this is enough theory, and we will see what is the practical of this knowledge in our browser now. So I just created a simple JavaScript file and then I linked it over here. So saying it as sloppy mode, and then we will see here. Firstly, I will print this keyword globally. So when I print this keyword globally, as I told you, since we are in the sloppy mode, let me just write it. This is the sloppy mode, means that the regular code that we write, sloppy mode. So globally, we should be getting the window as an object for the this keyword. So this keyword globally points to window because we are running the code in browser. And then coming to, I'll be creating two functions. One is the regular function and the other one is arrow functions. But I would like to create them inside an object. So let me create a simple user object with name property being Aravind, and then the function name f1, and this is going to be the regular function, and then another function f2, that's going to be the arrow function, because we need to understand locally we have two scenarios. What if it is a regular function, what if it is an arrow function? And then inside this regular function I'm going to print this. Inside this arrow function also I'm going to print this. So now to call the function f1, I can call by using user.f1. Now since f1 is a regular function, so it depends on the object inside the regular function, that this keyword depends on the object which invokes it. Object which invokes the function, right? So here user is the object that is invoking f1. So within this f1 function expression, that this keyword refers to user object. As you can see, we got user object. Let me comment this, right? And then similarly, when I call user.f2, this time f2 function is an arrow function. So inside arrow function, this keyword is not defined. So it should be accessed from its lexical parent. And you know who is the lexical parent of this arrow function? So this arrow function is a method of this whole object, which means this object is created being inside the global context. So global context will be the lexical parent for this arrow. So the lexical parent for this will be the global, right? So inside this, when we use this keyword, it should be accessed from the global. And we know in the global that this keyword stands for window. So over here, we should be getting it as window. Let me just save this, and we got it to be window. Now, one another way to call these two functions is again by assigning the function expression to some other variables and then calling them. So here I'll create two variables. One is x, and for this x I'm going to assign the function expression f1, and one is y, and for this I'm going to assign the function expression f2. Now I'm going to call x and I'm also going to call y. But firstly, so when I assign the function expression f1 inside the user object to x, which means this whole function value I give to the variable x. And when I invoke x, this time there is no object in front of x which is invoking x. So here in this scenario, this has literally no object which is invoking it. So the value of this should be undefined ideally. But it's not going to be undefined because there is something happens called replacement of this keyword. As we are in the sloppy mode or non-strict mode, there is a replacement of this keyword whenever whenever the function regular function is not invoked by any object. So this keyword here ideally needs to be undefined, but since we are in the sloppy mode, then this will be replaced with a global object. So this time we get the value of this to be window. So if I save this, we get window again. Now to call the function y, I can just use y. So calling y is nothing but calling this arrow function. Now again, inside arrow functions, always remember there is no meaning of this keyword, which means this keyword is not defined at all. And then the value of this, when we use it inside arrow function, you should be extracting it from its lexical parent. So the lexical parent of this arrow is still the global. So again, we end up getting the value of it to be window, however you call it. So let me save, we get the window for the second invocation again. So this is how this keyword works in a normal functions. Now I will create another two functions. One is function f1, and then inside this, I'm going to print this. Now I'll create another function called f2. So it will be an arrow function. And this time to call the function f1, I can call f1 just like this. And when I call F1 like this, there is no object in front of it, right? So when there is no object in front of it, this should be undefined. But since the whole code inside this file is in sloppy mode, so there should be replacement of this keyword with the global object, which is window. So for this invocation, we are going to get window in the place of it. Let me save it. We get window. Now similarly for the function f2, if we call the function f2 here, f2 is an arrow function. So the lexical parent of this arrow function is the entire global scope. So inside this, ideally this is not defined. So it should be accessed from its lexical parent, and in its lexical parent, which is global, that this stands for window. So over here, we again get the value of window. Look at this. Now we can also call regular functions in another way. Like for example, I'll just create a simple function called user. I'm just capitalizing the first letter because I would like to use it as a constructor function. If you don't know what is a constructor function, a regular function that can be invoked with new operator is what we call as constructor function. And remember, we can't make arrow functions as constructors. So whenever you have a regular functions, you can use new operator in front of it to make it as a constructor function. And the convention that we follow is to create the constructor functions is that we follow it with a capital letter. We start it with a capital letter. Now inside this, I'm going to print this keyword. And this time I'm going to call this function. If I call normally, definitely I'm going to get this as window object. Look at this. But if I call this function by using new operator, remember the task of new operator is that to create an empty object in the heap memory. So heap memory means it might be pointing to some memory reference. Let's say the address 500. So the new operator will create an empty object in the heap memory at some address. Let's say it is 500. And this new operator is the one now calling this user function. So it's like indirectly the function is being invoked by using this newly created object. So when this function is invoked by using the newly created object, definitely this keyword inside that will be pointing to the object whichever invokes it. Object which invokes the function, which invokes it. And this time the object which invoked the function user is this newly created object. So over here we get that object which is exactly the memory reference 500. So over here we get that empty object. And by default, when you use a constructor function or when you create an instance of a constructor function, that object will have the name of that constructor function, which is user here. So that's why it is just printed over here, but it's an empty object. Now, this is what happens in the case of non-strict mode or in sloppy mode. Now let us dive deep into what is strict mode and then how the values of this keyword varies in the case of strict mode. So for that, I have created another file called strict.js and I'll be writing the code here. Before that, remember the difference between strict and non-strict mode with respect to this keyword is that in non-strict mode, there will be a replacement of this keyword happens inside the regular function, but it will not happen in the case of strict mode. And to achieve strict mode, we can either make the entire file or entire module in strict mode by just using the directive called use strict. So if we use this use strict directive, then the code entirely will be in the strict mode. And remember, this directive has to be used at the top of the code. Let's say if you wanted to make the whole code inside this file or inside the global to be in strict mode, you will be using use strict at the very first line. Use strict at the very first line. And you can also make some function code to be in strict mode. For example, if you wanted to make a functions code to be in strict mode, again at the very first line of that function, you'll be using the use strict directive. So this is how we can achieve the strict mode. And the value of this keyword slightly varies in the case of strict mode with respect to the non-strict mode. Now let us see that. For that, I'm going to create two functions. One is f1, I'm going to call it as, and another one is f2. Now in both of these two functions, I'm going to print this keyword. I'm going to print this keyword here. Now if I call these two functions straightforward like this, then I will end up with window as the value. Look at this. We got window as a value because both are in non-strict mode by default. Now I'm going to make the first function into strict mode. Strict mode. So to make it in strict mode, we should be using the directive strict at the very first line. Now I'm using the use strict directive, and then this is in sloppy mode, correct? Sloppy mode or non-strict mode. And you see, both of the functions are not invoked with any object in front of it. So by the time I invoke the function f1, the this keyword should be undefined, as there is no function, no object which is invoking f1 in front of it. So in such scenarios, there should be ideally a replacement of this keyword happen. But since the code present inside this is now in the strict mode, there will be no replacement of this keyword with the global object, right? So this time we end up getting undefined as a value here. Look at this, we got undefined. Now coming to invoking f2. When we invoke f2 again, inside f2 we are not invoking f2 by using any object in front of it. And then this function code is now in the sloppy mode. So this keyword should be ideally pointing to undefined, as there is no object in front of it. But just because this code is in sloppy mode, there will be replacement of this keyword with the global object happens. Global object. So what we should get? We should get, in the place of this, we should be getting the window object. So that's what we get here. So this is how the difference between use strict and non-strict mode works. Now let us see one another example to understand it much better, where I'm going to create another object. Let me create a simple user object again, and inside this the name property is going to be Aravind. And then here also I'm going to have two functions, f1, that's going to be a regular function again, and inside this I'm going to print this, and then I'll create another function f2, and then inside this also I'm going to print this. Now the first function I'll be making it in strict mode. To do that, I'm going to use the directive use strict. So the function code is now in strict mode, and this one is however in sloppy mode. I'm not going to use the directive use strict in the f2. Now to call these two functions, I can just use user.f1 and I can use user.f2 as well. And you see, when I call the function f1, firstly, it is a regular function. So whenever we talk about regular function, then this keyword points to the object whichever invokes it. So this keyword here points to the object which invoked it. And you see the user is the object which is invoking. So this will be pointing to the user object. So let me save, and you see we get the user object. And similarly, when I call the second function, this is again the regular function. So that this keyword will point to the object which invoked this function. Now the f2 function is also invoked by the user. So this time again we are going to get the user object. All right. Now we know that there are another way to call these two functions f1 and f2. And that's when we create two variables like this, x, and we assign the f1 expression to x and then f2 expression to y. And this time, this whole function expression I assign to a variable x, and this whole function expression I assign to another variable called y. Now I'm going to call this x and y individually. So if I call this x, since it is pointing to this expression only, it's going to execute this function only. But this time there is no object in front of x which is invoking this function, right? So that this keyword should be undefined, as there is no object in front of x which is invoking it. So ideally, since it is a regular function, there should be a replacement of this keyword happen. But since the code is in strict mode, no replacement of this keyword, no replacement of this with the global object, this with global object, right? So since there is no replacement of this with the global object, we end up getting undefined as a value for this invocation. As you can see, we got undefined. Now the another way to invoke the next function, which is y, is that y and then this one. Now this time this keyword inside this will be again undefined, as y is called with no object in front of it. But since this piece of code is not in strict mode or it is in sloppy mode, there will be a replacement of, since sloppy mode, replacement of this keyword with the global object happens, right? So this time the keyword this inside this function will be replaced with global object. So we end up getting window object, as you can see. So this is how this keyword works in the case of strict mode. Okay. Now let us try to understand what will be the behavior of this keyword in classes. So inside classes. For that, I'm going to straightforward create a simple user class with a constructor, and that's going to take simple name, and then I'm going to set up the name property for the objects, right? And I'm going to create two functions. One is f1, that's going to be a regular function, and then f2, that's going to be an arrow function. And in both of these two functions, I'm going to print this keyword. Even in the first function also, I'm going to print this keyword. Remember one thing, understanding this keyword in the case of classes is a bit tricky. And most of the people fail to understand this keyword in the case of classes. Let's say if you're using class components in React, then you might be struck at how the binding of this keyword works. But trust me, if you can understand this, whatever I'm going to teach in the next 5 minutes, then definitely you're going to be done. And then you will understand everything in clear when you use class components in React. First thing is the code inside the class. The code inside the class is by default in strict mode. So just remember the first point that the whole code present inside the class is by default in strict mode. So whenever we come across strict mode, the first point you need to remember is no replacement of this keyword with the global object, right? Now, when we wanted to create an instance of this function, this class, I can just use let user1 equal to new user, and maybe I'll be passing my name here inside. And when you call the class constructor like this by using new operator, it's going to just execute the constructor method, right? And it's going to set up the property. Now, when we create an instance, try to understand it carefully. When we create an instance of a class, then that user one, let's say firstly, the new operator will create an empty object at some heap memory address. Let's call the address to be 500. The new operator created an empty object at address 500. And that address 500 inside the constructor will be pointed out by this keyword, which I explained just now in the case of constructor functions. And the same thing happens here as well. Now at this address, I am setting up a property called name with the value whatever I passed. So at this address, we get the name property with the value whatever I passed, which is Aravind. Along with that, as soon as the constructor is done, since it's an instance of user class, the methods which I specify within that class will also be a part of this user1 object, or this object which is created at address 500. Now this object will also going to have the method f1 and the method f2. So remember that these two functions will be created for every instance, which means if you create another instance, let's say user2, and by calling user constructor, this time by passing the Rajesh name. Now for this user2 instance again, the new operator will create another empty object at another heap memory address, and then that will be injected into the constructor. And in the constructor, the name property of this object will be set to Rajesh because that's the one I passed. And then for this user2 object, again the methods f1 and f2 gets created. Okay. So always remember the scope will be defined for every instance of a class, which means the user one will have its own scope, the user two will have its own scope, and likewise, if you create any other objects, for every object you are gonna get these two methods. And one more thing, these two methods will be recreated only when that is a non-static methods. You know, in JavaScript, we can also make methods to be static by just keeping the keyword static in front of them. Only the non-static methods will be recreated for every object that you create. So here, however, I created both of them to be non-static. So these two methods will be recreated for both the objects. Now to call the function f1 first by using user1, I can just use user1 dot f1. Correct. Now here f1 is what? It's a regular function. If you can see, it's a regular function. It's not an arrow function. So inside regular function, the principle is always same, that this keyword will point to the object whichever invokes it. So here the object which invoked it is user1. So we get this as user1, right? So we end up console log this to be the user1 object with the name of Aravind. So if I show you, it's the user1. Now if I call it with user2, then I'll get user2 object, because for this f1, which is this second f1, the user2 object which I'm using is user2. So that this keyword is going to be user2 this way, in this case, which is name Rajesh. Now I can also call the function f1 differently, but before that, let me also call the function f2 by using user1 again. So let me use f1 user1 here, and then you see I'm calling f2 function, which is this arrow function. And remember, in the case of arrow function, it's not, you don't need to worry about which object is invoking it, because inside arrow functions, this keyword is always not defined. That's how they are made, right? So there is no definition of this keyword inside the arrow functions. So when you call f2 by using user1 or without using user1, this keyword is always not defined. So it has to be getting it from the lexical parent of this function. And this function's lexical parent is not the global, but it's the environment of user1 or the scope user1, because as I told you, whenever you create an instance, that instance will itself have a scope. And in that scope, this always stands for user1 itself. So for this invocation, f2 invocation, this function will be pointing to the lexical parent as the user1 instance. So when you print this keyword within this, the lexical parent this keyword is going to be the user1 object only. So we will end up getting user1. Look at this. For example, if we call it by using user2, then this time this f2 is again also recreated for the another object called user2. So user2 dot f2 is nothing but this keyword going to point to the lexical environment, which is user2's environment this time. So this time we are going to get this keyword as again user2, as you can see. So this is what happens in the case of arrow functions. Now coming to, there is one another way to invoke these functions, right? Let me comment this too. I'm going to assign these two function expression to two different external variables. So user1 dot f1 and then y equal to user1 dot f2. Now the two function expressions, this one and then this one, I assign to two different variables x and y, right? And I'll be calling x. When I call x, as you can see, there is no object in front of it. X is nothing but this f1. So inside this, this keyword points to the object which invoked it, but as of now there is no object which is invoking it. So this keyword should be undefined. And here comes the topic of replacement of this keyword. Now, since I told you that the whole code inside the class by default be in strict mode, so there will be no replacement of this keyword happens. No replacement of this keyword. As if the whole code is in strict mode, definitely the methods inside will also be in strict mode, both the methods, right? Even the constructor will also be in strict mode, as the whole code inside the class is by default in strict mode. So since there is no replacement, we end up getting undefined as a value. Let me save this, we get undefined. Now coming to calling y. When I call y, however I call this y function, that's an arrow function, it should be getting from its lexical parent. Calling y of user1 is nothing but calling this function f2. And for this, the lexical environment is user1's instance. And for user1's instance, this keyword is going to be user1 itself. So we still end up getting user1 as the value. Let me save it and we get user1 value. So this is how this keyword varies in the case of classes. And remember the point that the code inside the class is by default in strict mode always. Now let us try to understand how this keyword varies in the case of modules. So for that I created another file, which is module.js. Now let's see how it works. To make any JavaScript file as a module, we should be giving the type attribute to be module. And remember, module is always like a scope. It will have its own scope. So in the case of modules by default, there is no definition of this keyword, which means the value of this keyword is going to be undefined if it is a module. You can see here it's undefined. So let me write that statement. This is undefined inside modules. And one more point you need to remember is when you deal with modules, because nowadays in the modern web front-end applications, we use modules always. Like we will be using modules only to make the React application where we divide the code into multiple modules, right? So for every module in the level of module scope, this keyword is undefined. That's the first point. And then by default, the code inside the class or module is in strict mode. So you need to remember this thing again. By default, the code present inside a class or inside a module will be in strict mode. So whenever we talk about strict mode, you should be triggering the point of no replacement of this keyword with a global object, right? Now I'm going to straightforward create another user object here to understand how it works in the case of modules. I'll name it as Aravind, and then I'm going to create two functions, f1 with function, and then I'm going to print this keyword. Now to call this function f1, I can use user.f1, and since f1 is a regular function, as you can see, then this keyword inside it will always be the object which invokes it. So here the object which invoked it is user object. So we end up getting user object, which is the whole object in the place of this, as you can see this. Now, there is also one other way to call this function where we assign the function expression to another variable, external variable, which is x, and then we can call that function x. Now, when I call this x, it's again going to execute this function, but this time there is no object in front of x. So since there is no object in front of x, the value of this needs to be undefined, right? And since the code inside this function or the whole code in the module is by default in strict mode, so there will be no replacement of this keyword with the global object. So it will not be replaced with the window object this time because the whole code is by default in strict mode. So we end up getting the value of it to be undefined for this invocation, as you can see. Now, similarly, if I declare another arrow function, let's call it as f2, and then inside this, if I print this keyword, now to call this function, I can just simply use f2 like this, user.f2. Now, for arrow functions, it's not a problem of how we invoke that function, but however, in arrow functions that this keyword is not defined, it should be extracting the value of this from its lexical parent. As this whole object is created inside the global, so the methods are also created under the global. So this method is also created under the global. Sorry, it's not global, it is the module because we are in a module right now, right? As I've specified it to be a module now. So the whole module, inside the whole module, I created this user object. So for this function also, the lexical scope is going to be the module. So in the module, that this stands for undefined. So over here also, that this stands for undefined again, as you can see. So this is how this keyword works in the case of modules. And that's pretty much about this keyword. And stay tuned for more videos about other topics. If you like the video, please like the video and then share it with your friends. Thank you for watching.